hope you're keeping well. As you can tell from my last math lesson post, I'm going a little bit crazy here in isolation, but you got to do what you got to do to cope with it. Today we're broadcasting live from a beach somewhere. As you can tell, I'm wearing for this occasion my jellyfish shirt. Hope you like it. I'm hoping that you were able to navigate trigonometry last day. It's not that difficult of a concept once you figure out what's going on. As I said, it is important for grade 11 and 12 math, as well as grade 11 physics next year, should some of you be taking that, if we ever do get out of isolation. That being said, we're going to continue on today. Today's lesson is going to be no new material really. We're just going to extend our learning a little bit from last day, work through a couple problems, and that'll be that. As always, if you run into any difficulties, please email me, send me a message over Edsby, post in the notes section on Edsby, and then myself or other classmates can help you out as well. And as always, turn to each other and get some help from each other. All right. So today we're going to continue on with trigonometry. We're going to focus today a little bit more on the sine and cosine functions. Last day was primarily the tangent function. Just remember our mnemonic here, SOHCAHTOA. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So when do we use these? Well, the answer is it depends on what data we have. So in a right angle triangle like this, let's call this 4, let's call this 10, let's call this 10.8. If this is our theta, if this is the angle that we want to find, we're going to use whichever one of these gives us, we'll use whichever one that we have the information for. In this case, we have information for all three sides, so the answer is we can use whichever one of these we want. If I do sine, and let me just label up here, this is our hypotenuse, this is our adjacent side, and our opposite side. Because for this angle I have opposite and hypotenuse information, I can use sine. I can also use cosine because I have adjacent and hypotenuse dimensions. And I can use tangent like last day because I have opposite and adjacent. Does it matter which one you use? Absolutely not. You're going to get the same answer. And I'll actually run through this with you to show you that you get the same answer every time. So if we use sine theta, that would be opposite over hypotenuse. Our opposite is 10, our hypotenuse is 10.8. And we get sine theta would be equal to 0.9259. In order to find out what that angle is, if you recall, we use our inverse function. So in this case, the inverse function is sine. And I get 68 degrees. If I do the same thing here for cosine, so cosine is adjacent over hypotenuse. We have 4 over 10.8. So our cosine theta here is 0.3703. Theta would be the inverse function of cosine. And we get 68 degrees. And I'll run that through that one more time with tan. So we have 10 over 4. So that would give us, and I'll skip a step here, so we'll eventually do the inverse function of tan, and 10 divided by 4 is 2.5, and we get 68 degrees. So it doesn't matter which one you pick if you have all three sides. If you only have two of the sides, then you have to pick whichever function that you have the data for. All right, moving on here. So let's just practice doing a couple questions here. If I was to give you cosine 29 degrees, what the ratio there be? So if you punch in your calculator, you hit cosine and 29 or 29 cosine, depending on which model you have. You should get an answer of 0.8746 rounded to 4 decimal places. And give sine 87, and I actually shouldn't have degrees here. Sine 87. Actually, I guess it doesn't matter. Sine 87, and as always, when you're going through these lessons here, don't just copy it down. Hit pause on the video, punch into your calculator, make sure that you are able to get the right answers yourself. And in this case, hopefully you get 9986 rounded to 4 decimal places. All right, just practicing another skill here. So if sine theta is equal to 0.7824, so in this case, sine is opposite over hypotenuse. If I take the opposite divided by the hypotenuse, this would be the answer I get. So we've already done part of this question. Let's take it the next step and find out what sine is equal to. To find out what sine is equal to, we will use the inverse function of sine. And we discover that that would be a 51-degree angle. Cosine r is equal to 0.5683. So instead of using theta, you might see it like this. This is in a triangle. R is one of the angles. We want to find out what it is equal to. Because it's cosine, this question is taking the adjacent and the hypotenuse side, divided them, and got this number rounded to 4 decimal places. To figure out angle R, we would use the inverse function of cosine. And we discover that R is an angle of 55 degrees. And one more question down here. So sine B, we want to find what angle B is. And in this case, sine is opposite over hypotenuse. We know that the opposite side is 7 long. We know the hypotenuse is 24. What would that angle B be? So angle B is equal to the inverse function of sine. 7 divided by 24 is 0.2917. And we get an angle B of 17 degrees. Just that easy. I hope it's easy for you. All right, so now that we have that under our belt, let's do a few application questions, and then we will call it a day. All right, our first triangle here. Reminder, this only works with a right angle triangle. I actually want to tell you something I don't think I told you last day. Always make sure your calculator is in degree mode. So on the screen, it should, I don't even know if you can see that. Looks like my pink is starting to fail me. You want to be in degree mode. So the screen on your calculator should have a D, or maybe it says DEG. Make sure it's in that mode for this to work. If you're getting the wrong answers, that could be the reason why. If you're having difficulty trying to get it into degree mode, you're getting the wrong answers, just Google your calculator model and name, and you should be able to find that. Or if you still have the instructions, I know that's the first thing I throw out is instructions for everything, but you should be able to find that information online. All right, so we have here, let's say that our hypotenuse is 15. Let's say our angle is 31 degrees, and we want to find out what x is. So quickly labeling up our sides. This would be our adjacent side. This would be our opposite side, and this is our hypotenuse. So in this case, sine 31 is equal to the opposite, which is our x, over our hypotenuse, which is 15. We do a little bit of cross multiplication, and we get 15 times sine 31 equals x. You'll notice that I took the 15 times sine 31. If you do sine 31 times 15, which is fine, then you will have to put brackets around the 15 to keep the 31 and the 15 apart from each other. Or you can just write it out like this. And when you do sine 31 in your calculator times 15, you should get an answer of 7.7. All right, and another example here. Once again, right angle triangle. This trig only works for right angles. Our hypotenuse here is 5. We'll call this 52 degrees, and we want to figure out what x is. So, if this is our angle right here, this is our hypotenuse side, this is our opposite side, this is our adjacent side. In this question here, we have adjacent is the side that we're trying to figure out. Hypotenuse we have. So since we have adjacent and hypotenuse, we're going to use our cosine function. So cosine 52 degrees is equal to a over h. Cosine 52 is equal to x over 5, subbing in the x for on the adjacent side and the 5 on the hypotenuse side. We do a cross multiplication. If you want to put brackets in, you can. And we discover that when we do this, we get 3.1. So that's the length of our adjacent side is 3.1. All right. So for this example here, we are going to solve the triangle. What does solve the triangle mean? It means solve all the angles. So I need to know what all 3 angles are. And it means to solve all sides. So you need to provide the length of all 3 sides. So if we have a right angle triangle here, this is 36, 18 long, and we'll call this side A and we'll call this side O, because this is the hypotenuse. So in this case, we have one angle that we don't know. We know 36 degrees and we know 90 degrees. And we only have one side here. So we're going to solve for the other 2 sides and for the missing angle. The first, let's try to solve here for A first, for the adjacent side. So because we are dealing with the adjacent side, and I'm going to use the hypotenuse because I know the length of that, A and H, we're going to use a cosine function. So in this case, cosine 36 is equal to our adjacent side, which I'm just going to call A, and our hypotenuse, which is 18. Doing some cross multiplication, I get 18 times cosine 36 is equal to A. And so when we do cosine 36 in our calculator, and then times that by 18, we get 14.6. So we know side A is 14.6. We need to find the opposite side here. And in this case, we can use adjacent and opposite, which is tangent. We used that yesterday, so let's use a different one today. Today I'm going to use opposite and hypotenuse. O and H is sine. So I will use our sine function. So sine 36 is equal to the opposite, which I'm just going to keep as an O. And that's going to be over our hypotenuse, which is 18. So sine 36 times 18. Just writing it a little bit differently than this question. Both are totally acceptable. You do it how you want to do it. And when we do sine 36 times 18, we get a value of 10.6. So that's 10.6. The last thing we have to do, so we have solved all sides. We do have one more angle to solve. We're not going to do anything fancy. I guess you can use one of these, but let's keep it simple. Let's just use our 180 rule from elementary school or grade 9. A triangle has 180 interior degrees. So if I subtract 90 and subtract 36, 90 and 36, I'm left with 54 degrees. All right, hopefully you were able to solve that question along with me. All right, on to our another example. So right angle triangle, 4.3, 8.2, and we're going to solve for angle Z here. If we're solving for angle Z, this is our opposite side, our adjacent side, and our hypotenuse. So to solve for angle Z, because I have one angle here, I'm going to solve for that one. I have opposite over adjacent. We're going to use our tan function like we did yesterday. So tan Z is O over H. Tan Z is 8.2 over 4. Nope, what am I doing wrong here? O over A. There we go. Sorry if I confused you. Tan Z is equal to 1.9070. To find Z, we do the inverse function of tan. And we discover that Z is 62 degrees. Perfect. Now we need to solve for side H. And I'm going to use A and H. Could use O and H. I'm going to use A and H. So I'm going to use cosine. So cosine 62 is equal to the adjacent side, which is 4.3 over the hypotenuse. If we do some cross multiplication, we get cosine 62 times 4.3 is equal to H. No, we don't. All right, sorry. We get H times cosine 62. Cosine 62 times H gives us that. And that's equal to 4.3 times 1 is 4.3. Now, because I want to get H on its own, I'm going to divide both sides through by cosine 62. They cancel each other out, of course. So I get H is equal to 4.3 over cosine 62. And we get a value here of 9.3. You would do cosine 62 in your calculator, round to 4 digits, and then divide 4.3 by it, and we get 9.3. So there we go, 9.3. The last thing to do is just use your 180 rule. 180 minus 90 minus 62, I think gives us something like 28. I guess in theory too, if you had A and B here, thinking Pythagorean theorem, you could have used the Pythagorean theorem to solve for H if you have two of the sides, but we're going to stick to trigonometry for now. All right, one more question, and then we will call it a day. All right. So in this case, we have an antenna, and it's being held up by, or it's being supported by a guy wire. So the guy wire to an antenna is 15 meters long. the angle of the wire to the ground is 48 degrees. Find the height of the antenna. All right, so in this case, our best bet is to imagine this as a right angle triangle. Trigonometry, this trigonometry is right angles or right angle triangles, so we have to figure out how to put this information into that. So in this case, we have the ground, we have the tower, and we have the wire. We know that this is 48 degrees right here. So the ground and the tower. So we know that the wire and the ground makes a 48 degrees. And the wire itself is 15 meters long. This is asking us to find the height of the antenna. So the antenna of the tower here is X. We have an angle. If I label up our three sides, the wire is the hypotenuse of the triangle, the ground is the adjacent side, and the tower is the opposite side. So, because I am dealing with the hypotenuse, because I have that 15, and the opposite side, because I want a tower, I'm going to use sine. So we know that sine theta is equal to the opposite over the hypotenuse. In this case, theta is 48 degrees. The opposite I don't know, I'll just call it x, and we get 15. Cross multiply, 15 times sine 48 is equal to x. And we discover that the tower, or the antenna, is 11.1 meters tall. All right, that is that. Give your homework a try. Hopefully you have some good luck with it. And we'll catch you next time. Have a great day, everyone.
There's a place called Kokomo.